Good afternoon, everybody. First of all, sorry about the slight delay, actually, but we hope that you will enjoy today during our fourth session about pasta processing technologies with Mr. Milan Shah from Alapala, and as our guest speaker, Mr. Enrico Mola from Perantani Food Solutions. Today, our webinar will take around 45 minutes, and please note that you can use the Q&A tab at the bottom of the screen to leave your questions during our presentation. We will try to reply as much questions as possible after our presentation, and the rest of them will be individually replied by email following our webinar. Let me introduce Mr. Enrico Mola as the co-founder and CEO of Perantani Food Solutions. Originally from Italy, Mr. Mola has studied in food technology and now holding PhD degree in food science, as mainly being specialized in cereals and dairy processing files. Having a total of 23 years experience in this sector, he has worked for Barilla, Pavan, Olam Grains, and Perfetti companies in manufacturing, R&D, and management positions. And now he launched his new corporate business based in Moldova and Nigeria for food ingredients and technical consultancy about pasta and other extruded products. Yes, now I'm handing over the speech to him. Mr. Mola, please, you can start your presentation. Thank you.
Hi, good afternoon, everybody. Thanks to join this second webinar about the pasta topics. And today we will talk about the process. In the first section of the webinar that we had in June, we talked about the raw material quality and the effect of the raw material to the pasta. And today we will have an overview and about the process of the pasta. I will share now the presentation, and I will be happy to reply to any question at the end of the presentation that you will make it through the Q&A that you will have in your Zoom desktop. Okay, let's start to have let's say a quick agenda. We will talk about the type of pasta and about the technology to produce pasta. Then we will go through a little bit a specific topic that is very important for the, let's say, standard drying pasta, that is the drying technology. And then we will have another topic that is important, like the technology that is the quality, the defect or the quality that you can achieve by a proper drying condition. Why I decided to concentrate and focus on the dry condition? It's because this is a typical question that my client make to me, and also because the pasta drying is a quite specific process that is typical for the standard Italian macaroni and spaghetti. This I used in my previous presentation. Let's start to understand how to divide the or categorize the pasta. Pasta, you can have a classification by raw materials. You can have a classification by shape of the pasta. You can classify the pasta based on the preparation of the dough or the processing after the preparation of the dough, and also about a packaging type. Obviously, in 45 minutes, we don't have time to explain all the process, but I will give you an overview about the main process to produce pasta. And then if you have any specific question, we can keep in contact. Okay, first of all, which are the main raw materials that are used in the pasta? Water, definitely. Durum wheat, semolina, again, definitely. Then you can have also soft and hard wheat or buckwheat, that is a very typical in Asia and especially China, and especially for what we call Asian pasta or noodles. Then you can use the maize flour that is becoming more trendy now for a gluten-free product. Rice flour, that again is a very typical in Asia and also became important now to produce a gluten-free or alternative pasta. Then we have eggs. Eggs are typically used in the fresh pasta and also in some dry pasta in the North Europe and Central Europe. Then we can produce pasta with legumes and alternative flour like pulses, like some other flours. And then we have another typical raw material that can be used is dairy and vegetable fruits. That is again typical in some area like Greek and Turkey. Then by shape we can divide the pasta in short cut and long cut. That is a very typical in the dry pasta. We have spaghetti and macaroni. Then we have the fresh shape that are typically tortelli, ravioli, and tortellini, and some other typical fresh shape like tagliatelle and so on. Then we have nest pasta that is like a nest of the birds, and it's very typical in South America, Italy as well, and Europe, a little bit less in Middle East and Africa. Then we have stamped or punched, that is the most, let's say, or the famous one is the bow ties, like the butterfly. This is a typical punched pasta because it's made by a specific machine. Then we have a flat pasta that again, the typical one, it's lasagne that are usually rectangular and flat. And then we have Asian pasta that it's a big category, and we can put inside ramen, noodles, udon, and rice noodles, and many other type. Again, this is, or we can say special pasta, but is inside the category of pasta. And then we have something that is again beside the pasta category, that is a couscous, that can be classified again in the big category of pasta because it's made by durum with semolina. Then the preparation, or we can say the preparation of the dough can be done by different systems that are the typical one that is a continuous process, and it's called mixing process, and can be speed mixer or normal main big vessel mixer with paddle. And that is the typical, again, technology used in the dry pasta that we know, like spaghetti and macaroni, but also in the fresh pasta. Then we have stamping and punching, like I explained, to produce the bow ties and and some other products that are very typical and regional product in Italy. Then we have a cutted pasta that is like a penny or macaroni that is known as a shortcut most of the time. Then we have another process that is resting. This process is typical for the Asian noodles, because after mixing, we have a phase of the process that is like 1 hour or 2 hours, or sometimes even 3 hours, it depends, where the dough, it will remain and rest just to distribute better the water and make effect of the additional liquid that you add typically in the noodles that is called kansui, and it has to make effect on the gluten formation and gluten network. Then after the resting, typically the dough is going to the lamination. That is another process where the pasta, where the dough is getting sheeted by a roller, laminator roller, and it's getting reduced the thickness up to 1.5, 2, or it depends, between 1 to 2 millimeters. And also during this process, he's giving some mechanical strength and power to reorientate and reform the gluten network in a way to give the typical texture of the noodles. Then you have a extrusion, that is, after the lamination, you have a grinding. Grinding, it can be before or after, it depends, and it can be two types of grinding or kneading. That basically it's another mechanical action that is being done to the dough, and it will again help to reform and structure the gluten network. And there is a different way to provide this mechanical power, that is through let's say a speed mixer or kneader extruder, or through a specific roller that they have a engraved surface, and they have like a fluted but extremely fluted surface, just to give this kind of grinding and kneading effect to the dough. Then we'll go to the extrusion. The extrusion is very typical in the dry pasta like spaghetti and macaroni and pancetta, but is also used in the fresh pasta for some specific shape that it's made by eggs, or sometimes even without eggs, but are sold in a fresh in a fresh mode, that is with 30 or 32% humidity. And then we have a kneading and forming, like we just talked before. Now, after you prepare the dough in such different way, and you form the product, you can you should go to process this kind of products. Processing can be drying, that is one of the most famous, and it's the most common in the long cut and short cut spaghetti macaroni, but is also common in the what is called egg pasta, in the nest, in the lasagna. Then you have another process that is called toasting, that is similar to drying, but it's a little bit more aggressive compared to dry, because you are going to reduce the humidity quite faster, and you are going also to have a, let's say, mild cooking effect on the product. And toasting is very typical in the ramen or noodles, because you can have the two kind of noodles or ramen. One is fried, another one it's toasted. Then we have a steaming. Steaming, again, can be used for two kinds of reason. One is a pasteurization, that basically it's called a heating treatment. And in another way, can be used to cook or to pre-gelatinize the starch. So in one case, in the case of pasteurization, is very typical in the fresh pasta. In the case of cooking or pre-gelatinizing, is very typical in the couscous, in the pre-cooked pasta or instant pasta. Then there is another process that is frozen, and it's very typical in what we call pasta ready meal. And we have various examples in Europe, in US, Asia, and Middle East. And we have another process that is cooking, but not by steam, but by water. And again, is very typical for the ready meal or pre-cooked ready meal. And then we have another process that is sterilizing. Sterilizing is, just to give an example, typical for the canned pasta, like in a US or in the Campbell soup. And this is done by retort in the case of can, or based on other technology if the packaging is different. Now, all these processing that can be mixed, done singularly or independently, or they can be mixed together. So there is no real fixed configuration, but with the same line, you can produce sometimes instant pasta, sometimes obviously normal pasta, and also instant pre-cook or sterilized pasta. It depends how you combine different processes. Finally, after finish the processing, normally you go to pack the product. Even the packaging is quite a big domain, but here I summarize the most common packaging in pasta. That is the pillow pack, that is the typical pack of macaroni and dry pasta, and also nest. Then you have a flow pack, that is the typical packaging for the spaghetti. And then you have a cup that is very typical for the noodles or ramen or instant pasta. Now they become more and more famous. Basically, you have a cup that is usually a multiple paper layer with polyethylene, and then with a sealing with aluminum seal foil on the top, with inside the seasoning or the dry vegetable. This is, as I said, typical for instant pasta and noodles. Then you have MAP and vacuum. That MAP is a modified atmosphere, and it's a very typical packaging for fresh pasta, because it will help to maintain the properties and the characteristic of the product longer in the time, and it will extend the normal shelf life of the fresh pasta. From typical fresh pasta has 5 to 7 days. With the MAP and vacuum packaging, you will extend up to 30 days. And with the chilled chain and the cooled chain, you can reach up to 45 days. And in some other specific case, you can even reach 2 months. Then we have, like I said before, a canning. Canning is usually typically for soup with pasta, so it's a mix between pasta and already vegetable or meat. Then after all this, let's say, big family of the packaging, you can go to the secondary pack. That again, there is a different varieties in the secondary pack, starting from the carton box from the wraparound, shrink wrap, and many others. Now, that is an overview of all, let's say, the main technology that are involved in the pasta domain. But let's go for something important. First, here you have an overview in this slide about the main raw material used in the pasta. Like I said, you have durum wheat, that is the name is Triticum durum, and you have the hard or soft wheat that typically is for bread or pastry product, but in the last, let's say, 20 years, it's becoming famous also to produce pasta because of two main reasons. The first one is availability. It's much more easy to buy compared to durum, that is a very niche product. And second, for the price, because due to the higher production worldwide and globally, the price of soft wheat and hard wheat is cheaper than durum wheat. Then we have a typical gluten-free, but not only gluten-free, because in some area they like to eat rice pasta, not because it's gluten-free, but because it's a traditional in that area. And here you can see just an overview about all the raw material that you can use it: millet, maize, buckwheat, quinoa, beans, chickpeas, lentil peas, and amaranth. Now, this slide I also used it in my last webinar, but it's important to connect to the rest of the presentation, because we need to understand what is important during the dough preparation and the mixing, and what is happening during the mixing. Let's take the standard dough that is made by soft wheat or durum wheat flour, soft wheat flour and durum wheat semolina, and water. During the mixing, the most important action are two, or we can, let's say, summarize in two. One is the restructuring of the protein characteristic of the flour, that they are going to be splitted in gliadin and glutenin, and then you have other two components that are globulin and the peptones. But the most important for the dough preparation and the dough processing are the gliadin and the glutenin. And then you have the reaction that it happens to the starch. We have to consider that at the end of the day, the starch is more than 65, between 60 to 65% of our kernel of our grain, and 13% is a protein. So protein are very important, but is also extremely important the composition and the quality of the starch. When you are going to add the water to the flour, you are going to start to initiate a reaction between the gliadin and the glutenin that are two different weight. They are two different weight, molecular weight and proteic structure. And I'm sorry. The molecular structure and the structure in the length of the protein, and in the characteristic, the physical and mechanical characteristic that is going to affect the quality of the final products. The second action that you are getting when you are adding water is the starch that is going to be divided between amylopectin and amylose. This is also due to the enzymatic action that you have in the flour, due to the enzyme naturally present in the wheat. But here you can see two pictures. One is the electronic microscope picture that can show the structure of the gluten when he is hydrated from the beginning. I mean, what happened to the structure when you're starting to add the water. And here is the hydration after providing the mechanical kneading effect. That is important to understand why you are mixing with the paddle, because, or why you are providing a kneading power and why you are processing the flour with the water to get the dough. This is exactly the answer, because to create a proper nutrient and visible gluten network, you need to provide a mechanical work. And there is no other ways, because you can leave the dough to rest, but the final result after resting, it will not be the same if you compare with a mixing action, because you need mechanical power to rearrange the gluten network. This is the reason why you are going to provide this mechanical work in a different way. And here you have a, let's say, very brief overview of the possible technology in the dry pasta for spaghetti and macaroni to provide this kind of mechanical actions. This technology, every producer, every manufacturer of the equipment, they have their own technology. But what I want to explain, what I want to try to make understand, that at the end of the day, you need a mechanical action, you need enough kilowatt, enough power to do the proper work to get the gluten. This mechanical power can be done in a different way and can be provided to the dough with a different method. Can be a double mixing vessel, like you can see here, with a pre-speed mixer. Can be a mixer, kneader, and co-extruder, that basically you have a kneader here that is a twin screw that is going to mix the flour and the water together and then going to the compression screw. This can be atmospheric or can be completely vacuum, total vacuum, can be longer mixing time or a little bit shorter, but at the end of the day, the condition must be the quantity of the power provided to the dough must be enough to rearrange the gluten and to provide the right network. Now, let's concentrate a little bit, because it's very important, to the compression screw. Once you mix it by kneading or by speed mixer and normal vexer, and you mix the water with the flour, you need to push and to send this dough directly in the compression screw. Before the compression screw, you must have a vacuum mixer anyhow, or you must have a vacuum area, because the dough in the screw has to be fed without, or as less as possible, air present in the dough itself. So now here is important to understand, when the dough is coming to the screw, roughly, because it depends which kind of raw material are you using, but we can say that the range of the density of the dough should be around 0.7 kilo, that is 700 grams per cubic decimeter. This is the average of the density of the dough if you mix it properly and if you add enough water to the mixing and to the dough itself. Should not be too much and should not be too less. Now, what is happening in the screw itself with different way to design the screw that can be variable pitch, can be variable core, or can be normal screw. But in any case, you should have always one section that is the feeding section, where you just move the dough, and you move the dough to another section that is the starting the compressing section, where you reach more or less, again, roughly 1 kilo per cubic decimeter of the density. And then, sorry, you have another section that is the last part of the screw, where you are increasing again the density of the product, but also you are increasing the speed to release as much and as fast as possible the dough from the screw. Here, at the end of the screw, you are reaching around 1.2, 1.3 kilogram per cubic decimeter. Then you have, usually in almost 100% of the screw, it's called the tree principle, that it will help to cut the dough flow and basically to remix the dough flow to avoid or to reduce the effect of the different viscosity of the dough and different speed. Because if you don't cut it and you don't remix it, the dough flow, you will have problem in the discharging part, because you will have some part that is going faster and some other part that is going slow. And you will have this, it will create the typical die effect that you can see if you look at the dies or at the front of the line, that you see the product, can be spaghetti, can be penne, is the same with a different length. This different length or different dimension, it's because you have a different viscosity inside the dough flow, and you have a different sum that it will go slower and it will make the product shorter. That's why, to reduce this effect, you have this part of the screw that it will cut the different flow and it will remix. Then after the screw, typically you have the head of the screw, that again, the head can be designed in a different shape, can be with this kind of angle and curve. There is some other manufacturer, they make in a different, but the purpose of the head is exactly the same, is to give a little bit time to the dough to stabilize and to take the dough and bring the dough to the die areas to make the shape. And the third purpose that is very important in the head is also to create enough counter pressure to the screw to increase the pressure and increase once again the mechanical work that you are giving to the dough to reach the point that is enough to make the proper gluten network. This pressure and this counterflow must be within certain range, because if it's not enough, you will have a poor gluten nectar. But if it's too much, you will have a gluten nectar destroyed. And normally the range, the proper range that you have, generally speaking, in the pasta is between 80 bars to 120 bars. This range is changing and depends on which shape you are producing, and it depends which product you are producing. But still, if it's too low than 80 bars, you will have a very soft product and the gluten nectar not yet formed. If you are going above 120, 130 bar, it will be a lot, too much, and you are going to have destroy gluten nectar, very hard, fresh product, and you will have consequences during drying and also during the usage of the finished product. Then, after this area, the head, you have the die. Die is the tools or the device, sorry, the device that it's giving the shape and the form to the product. In the pasta, we have more than 400, even more, even 1,000, 2,000 different shape, and each dies has his own shape. The dies are, I will show now just quickly a catalog of die to understand what we talk about. Okay. Obviously, I don't want to make any advertise, but I just taken, for example, okay. This is a shape. This is the insert, what is inside the body of the die. The die itself, it's not a very costly part within the equipment itself, but is absolutely a key for the equipment and for the quality of the product. Because if you don't choose properly and you don't maintain properly the die, you can have a very unpleasant effect on the product, because you can have a variable thickness, you can have a problem in the drying section, and you can have a problem in the shape and the dimension of the product. Normally, the die it's made by two parts. One is the body, that is made by bronze and aluminum blend and casting, and you have the insert. The insert are the part that is going to shape the dough. Here you can see this is a typical insert for the spaghetti, this one. This is the insert for bucatini. You can see, I hope, you can see the internal part that is making the core, that is making the true inside the spaghetti. And you have many other different shapes. You can have, let's say, the two main or the two most known dies are or full bronze or with Teflon. Typically, the pasta made by bronze are little bit more rough on the surface, and it will absorb better the seasoning, the sauce, but it will release starch. So you will have a little bit more starchiness effect in the cooking water, and you will have a little bit whitish effect on the surface. The Teflon extruded pasta is smooth on the surface. It will release less starch, and it will be a little bit more yellow color. Now we will come back to the presentation. So this is the two main difference between the Teflon extrusion die and bronze die. Now, let's go to the last topic. Unfortunately, I need to talk a little bit about physics because it's about the drying technology. Drying technology of pasta, it's a very specific topic and require a very specific capabilities to design the dryer and to manage the dryer for two reasons. Because first, dry the pasta is not important only the quantity of the water that you are extracting. That basically is from 30% humidity, 28 humidity after the shaping from the extruder to 11, 12% that you have the finished product at the end. So basically you are removing more or less 16, 17, let's say between 16 to 18% of water from the pasta. But a part of the quantity of the water that you are removing from the product, it's extremely important how you will remove this water, because how it will have direct effect and direct impact on several quality parameters of the product. So to understand this, we need to understand first few physical principles. Without entering too much in the details, about the quantity of the water that you are going to remove, that you need to remove, you have 4 parameters that you have to take in consideration. One is the temperature of the air that you are heating inside the dryer. Second, it's the humidity of the air that you are using to heat up and dry the product. Third, it's the speed of the air, so the ventilation of the air that is going to touch the product and remove the water. And fourth, it's the quantity of the water that is inside the product. Now, all these parameters, physically speaking, not quality speaking, are described in the Mollier equation and in the Mollier graph. Mollier graph you can use for any kind of gas, and the air it's a gas, is considered a gas, because for the physical discussion, we are considering the air just the pure air, basically the mix within nitrogen, oxygen, and rare gas. We don't consider that the air normally has also pollution, microbes, and dust, because this is something that is not possible to be calculated in the Mollier. Mollier is just calculating any kind of gas, how is behaving at different temperature, different pressure, and different conditions. So when you are going to design a dryer, you need to take in consideration all these factors plus the time, because obviously everything, the drying kinetic or the drying behavior, it's also connected to the time. So here, just to explain quickly, in the Mollier graph, you have the possibility by know the wet bulb or temperature, or relative humidity, or dry bulb temperature. You can cross this data and you can define the dew point, for example, that it's really important to avoid some mistakes. Dew point is what? Dew point is the temperature at which at which temperature the water is going to condensate at that specific condition. You can calculate the relative humidity if you don't know. You can calculate the wet bulb temperature. That is very important because the wet bulb is also corresponding roughly to the temperature of the product. So if you want to know the temperature of the product, that it's extremely important to understand the effect on the quality of the pasta, you can by using the Molière. And you can obtain also many other data, that is the quantity of the water in the specific cubic meter of air. So let's say that as a quantitative driver or for design the dryer, the Molière equation and the Molière graph are extremely important to understand how to dimension the radiator to calculate exactly which quantity of heating air you needed. You need to calculate the dimension of the fan to understand the speed of the air. You need to understand the most important thing, the quantity of the air that is going in and the quantity of the air that is going out. So please don't hesitate to make questions, and that I will reply later on if it's possible or by mail about this point. Now, the other important parameter to understand the quality of the drying, so you need, like I explained, to know how much water you have to extract. Then when you know how much water you need to extract, you need to know how you are going to extract this water from the pasta. Because another extremely important parameter, and let's say one of the most important, is the diffusivity. Diffusivity is a factors that it will tell you which is the speed and the power that you that the water will go from inside the spaghetti or inside the macaroni to the surface, because obviously the water can be extracted from the air, the hot air, only if it's in the surface part. Obviously cannot be extracted from inside. So you need to consider the spaghetti on the macaroni like a sponge. And obviously there is a time and the power and the speed for the water inside the sponge to move from inside to outside. This kind of factors, this kind of factor is the diffusivity. So if you are going against diffusivity, I mean, you are pushing too much, you are putting too high temperature to speed up the process and to try to extract as fast as possible the water from inside to outside, you are going to create quality issue. This is exactly how. So the diffusivity is directly connected to the elasticity of the product and to the material itself of that is composing the product. There is several complex thermochemical parameters to calculate the diffusivity. This is not the time or the situation to discuss about that, but there is a CP, there is a CT, that are all these parameters describe for each food materials which level of diffusivity you can have it. I can give you a very simple example. Try to notice if you are making coffee as it is, a black coffee, and at the same time, with exactly the same temperature, you are going to make a cappuccino, that basically is a milk and coffee. And try to measure the decreasing of the temperature. You will see that for the coffee, it's much faster. For the cappuccino, it's slower. The reason is simple, because in the cappuccino, you add the milk and you add a component that has a protein. The protein release the heating slower than normal water with coffee, because coffee as it is has a very, very, very minimal, almost nothing protein. It has just some fat and fiber and so on. So this is exactly an example to understand that the different materials has a different capacity to maintain the heating, and has a different capacity to release the heating and obviously the water. So if you don't do this part properly and you don't calculate exactly the diffusivity and obviously after the diffusivity, how to extract the water and in which time, you can create problems. That's why I give you a very quick overview of a system that it's working in the all pasta dryer, of course with some difference, but the principle are exactly the same. Basically, all the modern dryer, they have a system to control the quantity of the water, the quantity of the air that that is going inside, the quantity of the air that is going out, the speed of the air, and the humidity, and the heating system, the temperature. Because we call the modern dryer, they are a closed chamber. So you want to control all these parameters exactly because you want to apply in a proper way the best possible condition to dry as faster as possible, but as better as possible. So you need to control all the parameters possible to manage the how and the how much and the quantity. Now, by controlling the quantity of the air that is going inside and the quantity of the air that is going outside, basically you are controlling the quantity of the water that you are extracting, because you know exactly how much quantity of water you have in 1 cubic meter of air because of Mollier. So you know exactly at that temperature with that humidity relative, there is such quantity, such grams, such kilo of water that you are extracting. So again, to give an example, a simple example, if you have a 1 tons per hour line and you need to extract 18% of water, it means that you have to extract 180 kilo per hour of water. These 180 kilo per hour, you can extract only in 2 ways. Or they are going out by air, or they are going to be condensated. But you don't want to be condensated because you don't want to have a rain inside the dryer. Otherwise, your pasta gets spoiled. So you need to take it out through the exhaust or outlet. To take it out 180 kilo of water at the specific temperature, you need to take it out a X cubic meter of air. So for each drying zone and for each specific area of the dryer, from the pre-dryer to the hand, you have the quantity of water that you can extract. At the same time, obviously, if you extract air, you need to put inside the air, because otherwise you are going to create vacuum. So you know exactly also how to design the inlet, the air. And again, another characteristic of the modern dryer are that the air that is going inside is controlled by heating and by standardized the temperature. This is to avoid any possible modification due to the environmental condition outside that you cannot control. So, because you need to control everything, or as much as possible inside the drying process, you avoid any third or external effect. Then you have the fan. Again, due to the diffusivity calculation, due to the Mollier calculation, you need to know which speed you need to have on the surface of the spaghetto, because obviously to remove the water from here, you can remove by air. And obviously the speed of the air has effect on the time that you are spending to remove the water from the surface. So based on this calculation, you will design the fan based on the volume of the air that you have to move in certain time. Then you have another important parameter, that is the humidity, that is controlled by a probe that is measuring the humidity relative and the temperature. So for each zone, at each step of the production or the drying, you know exactly the condition of the cubic meter or the air inside the dryer. And all these things in the modern technology are automatically controlled from a PLC. And each producer has his own technology and software that can manage this automatically. Now, this is exactly what is happening during the dry. You can see the moisture, you can see the diffusion inside the spaghetto, and you can see how it's going to change the presence of the water inside the spaghetto and during the typical phase of the dryer. All the modern dryer, they have a pre-dryer phase where you try to accelerate as much as possible the water diffusion and to extract as better and as fast as possible. You have the dry part where you are extracting by a little bit longer time the inside water. Then you have a phase called stabilization, where you are going to distribute the water properly. Basically, you are going to flat this curve in a way that the water is well established inside the spaghetto. Then you have, if it's required for specific shape, a moisturizer or moistening phase, and then you have a cooler. These three parts are because the modern dry, they use to dry the pasta very fast. So due to the short time that you require to dry high quantity of pasta, you must have a stabilization process, moistening, and proper cooler, because otherwise you will face quality issue later on. Now let's go to and I'm going to finish. Let's go to the three main issues that we can see on the finished product when it's not proper dye. The first most common is the cracking after the drying process. This is, I think, many people they saw on the spaghetti that they have this kind of white surface inside the spaghetti itself or macaroni. And this is due typically for a fast drying, and you didn't remove properly all the water. You create a crust outside, and you are going to trap the water. So when you are going to store the product in the warehouse, the water start to move outside. So when he's reaching the surface, he found a strong crust. So he's going to create a tension, and this tension is cracking the pasta, because you should remember something. The pasta is a live product. So it will be always in equilibrium with the environment and ambient condition. So if you are in a very humid environment or very dry environment, the humidity of the product, even after packing, is gonna change. So if you don't dry in the right time and with the right power of drying, you can face this issue. Typically, to solve this issue, you have to recheck all the probe and the device and the valve on the dryer to understand if there is some problem of calibration. So there is some probe that is not measuring properly. This is the first job that has to be done, because in the modern drying, if you have some probe that is not working or is not measuring properly, or you have some fan that is not working, or you have some valve that is not moving proportionally and correctly, it's like you are driving blind. So before to assume any issue or any reason for the cracking, first you have to be sure that all the probe, valves, and fan are working properly. Once you are sure that this is working properly, you should check the moisture of the product in each phase, and you have to revise probably the diagram. But you need to be sure first that everything is working, second that the quantity of the product is exactly the same when you start the commissioning, and is exactly the capabilities of the line. Another defect that you can have in the pasta due to the dryer is the burn. This is the typical small fire sign or fire bubble, and this is due to a very intense kinetics or very high temperature in the pre-dryer, typically, because you try to take it out the pasta, take it out the water too fast, and you are basically burning the pasta. Here, the suggestion is exactly the same like before. Check everything, and then maybe you have to revise the diagram or to adjust some parameter. One of another main quality issue is that when the spaghetti is going to stick each other, and basically this what is going to create is problem in the stripper, problem in the packaging because you have a double or triple or four spaghetti. So in this case, the reason why is because the surface moisture is too high, and due to the movements inside the dryer, the spaghetti can be contact to each other. So when you have a lot of water outside and you have high moisture content in the air, the spaghetti can be stick each other's. The suggestion is exactly the same like before. You need to double check the drying condition and how you measure and you control this. Thank you very much to listen me. And today I took a little bit longer, and I apologize for that, but it was quite a complex topic. Now, if you have any question, please, I will be happy to answer. And I will stop sharing the video.
Enrico, thank you very much for your presentation. And actually, we have a few questions. Maybe we will start with the first one from Mr. Vivek Kumar. What will be the environmental impact on maintaining the moisture in the pasta process?
Okay, if Mr. Kumar is understanding, it's meaning the factory environment. I always suggest that in the drying area, you should have at least not less than 28 degrees and not more than 34, 35 degrees, with a moisture around 60 to 80% maximum. If is meaning the condition inside the dryer, obviously I cannot answer now because it depends on which dryer they have and it depends on which technology. But another important thing that is key to maintain is to avoid any external air coming inside. So I always say to all the pasta factory producer or the pasta factory client that they have to try to keep the factory under pressure. Usually the best level of pressure to maintain is 0.2, 0.25 millibar of pressure of the factory. So when you are opening the door, you need to feel the air coming from the factory to outside, not vice versa. The other question?
Yes, actually, this is also more or less the same, but from Mr. Sharat Kumar that he is asking for the impact of environmental conditions, temperature and humidity.
So I repeat, between in the process area, between 28 to 35. In the packing is different. So another thing is, if I strongly suggest to divide and to segregate the drying and process area with the packing area, because in the packing area you should keep a normal environmental ambient temperature, or if it's possible, because there is obviously manpower and operator, it's suggestible 25, 26 degree. But the two areas, the drying and the packing, has to be divided. And the third thing is the humidity between 60 to 80, and obviously as much as possible dust free. You have to avoid to have a dust inside the drying and obviously the mixing area.
Okay, thank you, Enrico. And one other question: what type of extrusion is most widely used in pasta process, and the compression stage of dough in extrusion?
Screw. Okay.
What exactly happens to the gluten network?
Yeah. Okay. First of all, the most widely used in the pasta process is it's a screw with a pitch that is going to decrease. So it's a variable pitch screw to have the central part has a compression area, and that is, let's say, widely common for all the producer, with obviously some difference because the profile of the screw is a part of the technology and a part of the core technology of each manufacturers. And what is happening inside the screw is many different mechanism and action, but on the gluten specifically, basically they get stretch the glutenin, basically the glutenin they get longer, and the gliadin they get pushed inside, and basically is like to stitch a net. Basically you have the gliadin that are the glutenin that are the textile, and the gliadin that are the stitching fiber that is helping to maintain the network, and also is shaping this network that basically from a random shape of the network is getting to be little more like a mesh network. That is what mainly happen in the screw, but obviously not only.
Thank you, Enrico. And one more question with a small suggestion about timing of this webinar from Mr. Khalid El-Mutir.
Yeah, we will send. You can tell them that we will send a copy of the presentation.
Yes, for sure. He is just asking for the ideal size of semolina, which is good for making pasta.
Okay, and the ideal semolina, if you mean durum with semolina, is, like I said in my last webinar, above 250 and between 250 micron and 320, 350 micron, you should have 80%, 85% of the granulation profile. Then you can have another 5, 10%, or even maximum 15 below 200, 250, and you can have 5% around 400. This is for durum with semolina. For soft wheat, you should try to have as coarse as possible. So you need to change, like we said last time, completely the approach, and you need a coarse flour. So you need to have the 80% of the granulation profile above under 80 up to 250. And you need to have 20%, or let's say 15% below under 80, under 50 micron, and 5% above 250. For many several reasons, because of the starch damage, because I didn't say, because I explained last time, the starch damage in the pasta flour or durum with semolina must be less than 3%. So it's a completely in the opposite way compared to bakery or bread flour. Now, how to control cooler of pasta in the final product? I think is meaning how to cool in the best ways possible. So you need to have a system that is controlling the dew point. You need to have a system that is filtering the air, if it's possible, because the air with dust is going to close and to make dirty the radiator, and so you are going to reduce the efficiency of the radiator. So, and you need to control the dew point of the cooler. This is the best way to cool the pasta. So you need to keep as much as efficient as possible the cooler, because usually the cooling time is very limited. So you need to keep the cooling efficiency higher as possible, and you need to control the dew point. To control the dew point, you need to be sure that all the probe are proper calibrated and accurate. You need to check if there is any sign of condensation inside the cooler. And if there is a condensation, you need to understand why there is a condensation and from where. And you need to keep very clean the radiator and the cooler itself.
All right, we have only one more question, Enrico.
What is the point
yes.
that you pay attention while deciding expiration date? Okay, usually the expire date in the pasta, it's between 18 months to 24 up to 36. But frankly speaking, because the humidity it's around 12%, and more important, the water activity is less than 0.4, 0.5, you don't have really microbiological issues in the pasta. What you can have, it's more due to the infestation. And this, I want to clarify something very important. Infestation in the pasta, basically the weevils or the insects or any other kind of infestation, they are not coming at all from the product itself. So when you have insects inside the pack or inside the product, is because it's coming from an external infestation. And typically the reason is because you are mixing finished product of pasta with flour, with bag of flour, or because you have a poor condition, hygienic condition in the warehouse, or because there is a poor hygienic condition in the distributor warehouse, or because the carton, the outer carton itself, they are infested, because the carton are the most, let's say, liked place to put the eggs of the insect, because you have a strong infestation in the factory or warehouse itself. So generally, always when you have infestation in the pack, the problem is not the pasta, but the problem is outside. You don't have any specific microbiological issue in the pasta because it's dry, it doesn't have high water activity. Obviously, you need to keep the hygienic condition of the line up to certain standard, because in some countries like United States, like Canada, it's they are controlling also the toxin level that can come from the mold coming from the silos or wheat and so on. So it's always good to keep clean, but the shelf life of pasta can be extended up to 2 years or 3 years, but you must be sure about the external condition during the store of the product. Okay, for me it's enough. I just want to reply to a last question that is asking me about the kansui for long cut pasta, and obviously not at all, because the kansui that is typical for ramen and for noodles is not good for dry pasta, because the kneading process is totally different, and also the cooking, or let's say drying or fried process, make a different effect on the texture of pasta. So kansui, it's not at all usable for long cut pasta. Thank you, and I think we will answer to any additional question by mail, like as usual, no, Mr. Milan?
Yes, we will answer any questions by email. And Enrico, I will take this occasion to thank you for an excellent presentation. Thank you very much. And thank you, our viewers, for joining us this afternoon.
Thank you very much to everybody, and I wish you a good pasta making to everybody.
I hope this has brought some enlightenment to everyone about pasta.
Yes, sure. Okay. Enjoy the rest of the week. See you again.
Thank you. Thank you, Enrico.
Thank you very
Bye.
much.
And thank you, viewers.